Today I'm going to finish modifying my PLC that has 120 volt AC in. See if you can see that. And what we really want is a 24 volt DC because it's a lot easier to work with, and most of the inputs are 24 volts. So I already restarted some of the changes. You can see I replaced the capacitor with a resistor. I'll show you the schematic and you can see how that enables us to use 24 DC versus 120 AC. So here we have our board set up in our little vise. The soldering iron's heated up, and you can see the capacitors are right there. I have to remove each one of those and replace it with a resistor. Now this is a RoHS compliant part, which means they use lead-free solder, and that requires a higher temperature to melt. So sometimes it can be a little bit harder, but just turn up the temperature and it should be fine. Sometimes I use a little extra solder to help loosen it up. And if you're quick enough, you can do it with your hands without burning it. Alright, all the caps are out, and we're ready to clean those holes up and put in the resistors. Okay, to clean out the holes, I try to attempt to use one of these little vacuum plungers. Okay, so looking through our parts bin, I was able to find some 2.2K resistors. I think they're maybe a 1 or 2 watts. That should be plenty for what we need. So we will install those and then we should be done. Alright, there it is. I can see how I staggered the resistors so they're not quite right next to each other. That's so it'll have better heat circulation and dissipate the heat of the resistors better. No, I'm just bullshitting. I just think it looks cooler. Okay, we have it partially put back together. I didn't put the bottom cover on yet, just to make sure everything's working before I assemble it. And I have it hooked up to my power supply, 4-channel power supply. we're using channel 1 and 2. Channel 2 here is connected to the 24 volt in power supply for the PLC, and then the other channel we will hook up to the input side. I've already connected the grounds together so we don't have to mess with all those wires. So we set channel 2 to 24 volts, and then let me turn the current down a little just in case. And same with channel 1. And I'll turn it on. And we'll have to come back to this as duty calls. Alright, now we will turn this up. Let's say start at 24. Here's our power, and let's see, our input LEDs are gonna be over here. So let's try channel 1. And we get nothing. Probably because our ground wire fell out. Okay, our ground wire is secured. And we'll try channel 1. And there it is. Or they start with 0. There's 2, or 1. So they all work. Let's see how low voltage we can go to. Last time I checked it was about 17, so I'll try 18, see if it still lights up. And sure enough, at 18 it still lights up. And we'll go back. Let's try 15. And at 15 we don't get anything. So let's say that's a success. Converted the 120 volt AC input to 24 volts DC. And that is a A-B Micro830.